Up and running. Okay, great. So basically, Carlos is going to show you how to get started with Matrix Core, how to like do some examples, how to program it in JavaScript, and he's going to explain like just Matrix Core and how it works and everything. So if we go switch the screen sharing.
Yep. Give me 1 second.
Let's see.
All right.
Good. Working. Yeah.
Is your stream working?
All right.
Okay.
Yeah.
Cool.
Nope, that is not what I'm looking at right now.
It's it's frozen.
Hold on.
Let it go. Let it go.
Is that what you're looking at?
There we go. Yeah.
Oh, okay, cool.
Perfect.
All right, so, okay. Can you have the profile?
Yeah,
I guess we could
Just
do
yeah,
that.
keep talking. I will.
That's
I will.
Okay,
Fix
so,
it.
hi everyone. I'm Carlos. If you remember me from last video, well, I think like 2 weeks ago, I went over how to set up your Raspberry Pi and install just HAL. And right now what we're going to do is I'm going to assume that all your Raspberry Pi is set up, and I'm going to start from the point where you just have the latest version of Raspbian Stretch installed, and we'll start from an SSH session.
And if you don't have that set up, then you can go to our video episode 101, and that's where Carlos is showing you how to set up your Pi with all the software you need. Okay?
So to get started, assuming you have the device set up, you can just go to the tab on the side.
And he's on our documentation page, so that's docs.matrix.1.
Mm-hmm. And to get started, just on the left-hand side of the navigation, just scroll on down and you'll see Matrix Core. You just click on there and immediately just hit Getting Started and Installation. And from there on, it's just basically a copy-paste adventure. So what you should do after is have your terminal open and SSH into your Pi. Default password is always Raspberry, and the username is Pi. You can see it right here. There we go. And alright, so the moment you log in, you have just a regular terminal into your Pi. You go into the Matrix Core docs page, and from here we'll walk you through the steps of what you have to do to get your Raspberry Pi set up with Matrix Core. And obviously, make sure you have your Matrix voice or creator attached to the Pi. So just one by one, we'll start copying each command. And to save some time, we've also already ran these commands, because normally the updating and upgrading would take around like a 15-minute process.
Which happened to us in the last stream, so we learned.
So to avoid that, we've done it beforehand, but we're still going to run the commands, just to at least, show you how it would look, just not as fast. Okay, so we install the packages for Matrix Core. All it'd be left is to reboot. Okay, so give it like a good couple seconds after that happens. Let's see when it goes back on.
It'll take normally like 15, 20 seconds to come back on. At least if you have like a Raspberry Pi 3 or newer.
Yeah, right now we're using a Raspberry Pi B, right?
Yeah, 3B.
3B.
Yeah, not the latest one, which is the B+.
Yes, okay. So the Raspberry Pi rebooted. So we have the packages we need for Matrix Core, and now we're going to install ZeroMQ, which I will explain why we need that in a moment. So install here, and let's see, it's connecting. Oh, and also a heads up, if there's any kind of installation issue, normally it can just be fixed by running sudo apt get upgrade and update. You'll see the command. I mean, we've already ran the commands here, but just in case there's any connection issues, that would normally resolve it. So let me just close that. Okay, so assuming you ran through the first step here, that just installs Core and you have it running on your Raspberry Pi. So once you have there, you're going to want to scroll down to next steps. And with Matrix Core, we provide multiple language options. We have examples in Python and JavaScript, as well as the libraries provided to make it easier. But you can use any language that supports Google's protocol buffers and ZeroMQ.
And do you want to explain a little bit of like what Matrix Core is and how it works?
Yeah, I'll explain that in a second.
Okay.
So, for this tutorial, we'll be using JavaScript, Node.js. So you click here, and you'll be installing Node version 8.6 on your Raspberry Pi. So these commands just install it automatically, just copy and paste. Let's see. Well, once you run the command, I'm going to be skipping this to save some time, because it's already on here. So the command right here, creating a Node.js application, this is just what we're going to run you through is a hello world, so how to make a Matrix app just right here. So copy and paste these commands, and automatically you'll make a folder called JS Matrix Core App, which you can see right here. And then we're going to run npm init, which initializes a node module. So immediately, you can just hold enter to skip through these settings, and then we'll stick with the default. If you press ls, you can see we're already inside JS Matrix Core App with package.json. So now that's done, you're going to want to install the libraries. So what we're going to install is the 0MQ package, which is basically one of the main components of Matrix Core, and the protocol buffers you need to actually interact with it. So while this is all installing, I'll be going over exactly how Matrix Core works. So you go here on the side, in Getting Started, you'll see Understanding Core. So just open that right here. Alright, so to give an overview of Matrix Core, the best way you can think about Matrix Core is that you're communicating with the server to send and receive information. So how this works is that on the left here in this graphic, let me just zoom in there for you, you'll have your app. That's the app you write in either Python, JavaScript, or whatever language you decide to use. And from there on, you'll be using 0MQ, which is it's an asynchronous communication framework. And you're basically using a 0MQ server to send protocol buffers, which will be read by Matrix Core, which has services in the background. And protocol buffers are essentially, I guess you can think of it as an alternative to XML or JSON. It's a way for languages to read information between different languages. So right here, as you can see, your app is sending and receiving protocol buffers to and from Matrix Core. So if you scroll down to ports and protocol, for each component of Matrix Core, say like the IMU sensor, the humidity sensor, or the Everloop, which are the LEDs on your Matrix Voice or Creator, we have different ports to interact with. And I'll get to that in a second, but just know that each component has its own special port. And the reason why we have our ports, each component has a total of 4 ports. That would be here, let me close this for you. We have 4 ports. We have the base port, keep alive port, error port, and data update port. And I'll go over what each of them does right now. So the base port is where you send information to the component you're editing. So say you want to change all the LEDs color to red, you would use a base port to send a message with you send the protocol buffer specifying all the LEDs that you want them to turn red. So that would be an example of what you'd use a base port. Or how fast you want the sensor data from like an IMU, so like a gyroscope. And the keep alive port is a message you send. So when we're sending you sensor data, we expect the keep alive message to make sure that you still want the data. So that's basically all it is. Usually we just ask you to send an empty string. And if you're confused right now, we'll be going over the actual code for this, so you can actually visually see how this works. This is just to explain it. The error port is actually optional. We highly recommend you use it, but the error port is for any error logs that come by. We'll send it to you through the error port here. And I mean, you could avoid it if you want, but it's recommended. And the data update port is, say, for a sensor like IMU, temperature, humidity, we'll send you the actual values through this port. So that's essentially all you need to know about Core. It's essentially just interacting with the server, sending and receiving data through 4 ports. And that is all you need to know. So now let's see if the JavaScript, no, it's not done yet, but should be done pretty soon.
Yeah.
Let's see.
And so the great thing about Matrix Core is that since we've built it on these protocol buffers and 0MQ, we're basically able to support a whole plethora of languages. So we've already built the protocol buffers so that you're able to easily program it in Python, in JavaScript, but then to make more protocol buffers for, let's say, Ruby or Go or any other language that you want to use it with, it's really simple. So with that, it just allows you, it's relatively simple. You kind of need to know what you're doing more or less, but it's not a month-long project. You could do it in, let's say, a weekend. And if you already know how to use protocol buffers and the language that you're trying to do it with, then it'll be even easier.
Yeah.
So I guess I'm finished now.
All right. So if you notice right now, our node project has a node modules folder, which contains the 0MQ library and the protocol buffers library for Matrix Core. And that's all we need to get started. So if you go here, just to make sure everything works, right here, check if everything works, creating an app.js file. So right here is the hello world to just randomly change the LEDs on Matrix Creator. So right here, we'll just make a quick file, call it app.js. and then I'm just gonna copy and paste the stuff in there. So I'm using a Nano editor. So for those of you that are new to Terminal, it's just a way to use text editor but inside Terminal. So if you want to follow along, just type in Nano and the name of the file you want to create, and then this is just a text editor where you're editing the actual file. So here I'll just paste the code I just copied, Control X, click Y to confirm, enter to save, and then if you look here, I've added app.js showed up in the project folder. So now all you have to do to run it is node. We have the creator. So right here, type in node app.js. And there we go. And yeah, that's it. Once you have this ready, Core is completely set up and you can interact with all the libraries that we provide for you right here. So let me just stop that because that is bright. Okay.
Yeah, let's put this upside down.
Yeah, turn that around. Okay. So now to actually break it down for you. So I think to start simple, we'll start with the IMU sensor, which is what has the gyroscope, accelerometer, magnetometer, and that's
it.
Yeah, so those three. So right here on the side, let me expand it a bit. Once you're here and you check everything works, we even have a GIF here to visually show you on the voice. Next steps, you want to look at the JavaScript examples. The driver protocols, which you can find right here, are the protocol buffers, like the actual message before they're compiled for JavaScript. So you want to click on the JavaScript examples and then go to IMU. Once you're in IMU, we explain each of the ports that they use. So the base port, which is the port you send data to, keep alive port for making sure you want the actual sensor values, the error port if any errors show up and you want to learn about them, and the data update port, which will actually extract the sensor value. So to get started, all you're going to want to do is right here, back into our project folder. What I can do is I'm going to make it a bit more easier to understand, use a text editor on my computer to actually visually to get a better understanding of what I'm doing. So really quickly, I'm going to use a program called CyberDuck, which will let me SFTP into the Raspberry Pi. Do the 168.1.83. So Pi. And here I'll use an actual text editor that I personally use while I program. So here we're gonna go edit the app.js file I used.
And just to explain, like CyberDuck basically allows you to access the files on your Raspberry Pi or any other device that you want to connect to, and from there you're able to like open up the files on there in order to edit them locally on your computer and have all like the syntax highlighting, and just it's much nicer to use rather than just doing Nano in the terminal.
Yeah, and for the shortcut that I'm using to open it like this, because the way this works is that I can use my own text editor, and if I press Command K on Mac, or if you're using Windows, Control K, it'll open up a text editor where any edits you saved, or any edits you make and save are pushed to the Raspberry Pi in real time. So right here, the app.js file I'm editing is the one I just made to show you the hello world. So let's go back here. So this is the IMU example. So to get started, these are the initial variables you need. So here we have the 0MQ library we're importing. Right here, line 1, 0MQ library. Line 2 would be the matrix protocol buffers. The local matrix IP, which is just local host or 127.
That's the like internal IP for your matrix device.
And then the IMU base port IP, which for all the IPs of any component we show in Matrix Core, you can find all the IPs right here under Overview. We'll say available 0MQ ports for each one. And if you notice, each of the ports are one above each other. So from 2013, it reserves that port and the 3 above it. So in reality, you only need 1 port and add 3 above. So to get started, so once we have the initial variable set up, we're gonna go through each port one by one. So we'll have to start off the base port. So right here, you can just copy, paste. There we go. So make big comments to make sure you know what you're doing here. So base port, and make it a little bit more obvious here.
Carlos loves his comments. In case you didn't know, Carlos actually made all of the MOS and Matrix Core documentation on the documentation site, and so all the amazing comments on there and the thoroughness, that was all Carlos.
And so we try to have every line commented. So if no matter how new you are, we try to explain everything we're doing And we thought worst case scenario, it's easier to complain. It's harder to fix a lack of comments than too many comments on your side. So that's a philosophy we went with. So for the base port, this is all you need just to send a configuration. So for the IMU, what you send are two things. How fast you want the updates and when the timeout is. The timeout is basically when you send your keep alive messages, basically when you stop sending keep alive message, or like how the tolerance of how much to wait it for, or
Yeah, it's basically so like let's use an analogy. So let's say you are trying to connect to the internet and it's not working. It's like how long it will keep trying until it gives up.
Yeah. So if you stop sending keep alive messages, it'll wait 6 seconds until to make sure that you stop sending it, and then just completely stop. You don't really have to worry about that. We just want you to know what it does. And the delay between updates is up to you, how fast you want to set it. And then that's all you need for the base port. And to walk through the lines one by one, we have the first part is with 0MQ, because that's the you're connecting to the base port, so you're going to be using 0MQ. So here you're going to make a push socket, which we'll call config socket, and then you're going to connect that to the base port. As you can see, the variables, we're using the IMU base port, and then just put it here. And you can just copy and paste and just take this. We don't want you to do any thinking when you're using this, so we just provided all the examples to work from copy and paste. And then once you make your push socket, you're gonna want to make the actual configuration message. So inside the configuration message, there you put in the delay between updates and the time after ping. And once you have that configured, you actually just send it to the 0MQ server. And that's all you need for the base port. So now the next port, which would be the keep alive port. So keep alive port, it works the same way as the base port, but instead of sending a protocol buffer, what we'll be sending is a empty string. Because for the keep alive, you just need to ping it. It doesn't have to actually contain anything.
Yeah. So you're just like constantly telling it like, hey, I'm still here, keep sending me data.
Okay, and same thing. You make a push socket, connect to the base port, and we're adding a +1, because if you look right here, the keep alive port is just one above the base port. So just if you wondered why, send an empty string, and then and this set interval function is just an endless loop to keep sending it every 5 seconds. All right, and then that's all you need for the keep alive port. Now the error port. So to do that, copy and paste. Let me just add those comments. Keep alive. Error port. There we go. All right, so the error port. Now, instead of a push socket, which we were making before, we're making a subscriber socket. So if you look right here, instead of, let's see, compare it to these two. So instead of push, we're making subscriber, because what we're doing is listening to messages. In this case, we're listening to error messages. So same as before, once you make the socket, connect to the port you want, which is the IMU base port +2, which translates to port number 20,015. And of course, we don't expect you to remember these. We have them all labeled for you. And then you're going to want to do subscribe the socket to the port. And then right here, on any message that you receive on this port, we'll just log it. That's it. This logs to your terminal, and you can do whatever you want with that error message. So one possible error you can have with the IMU part of Matrix Core is that maybe you send a wrong configuration message. If you mess up the base port per se, the error port will let you know that it received a wrongful configuration message. So that's all you need for the base port. And now for the last part is the data update port. So copy paste. There we go.
Gotta have the comments.
Yep. So let's go right here. Data. Oh. Let's make it a little nicer. And then just nitpicky. Okay. And now same concepts that we went over in the error port. For the data update port, you're going to make a subscriber socket, connect that to the port you want, which is the data update port, subscribe it to all the messages, and then just like that, on any message, which will be the, we'll actually show you right now. So the message you get from the data update port is a JavaScript object, since we're using JS, and all the messages here, here's an example message. It'll give you an object, and then you can just pull the values you want directly. So you can have yaw, pitch, roll, accelerometer, and magnetometer, and just do whatever you want with those values. So we'll save that, and then that was instantly pushed into the Raspberry Pi. So if we go back here, let's run app.js. You have to see. Oh,
what?
I think. Let me see. Let me make sure everything was configured right. So go reboot. Let me just reboot to make sure everything was okay.
Yeah. And to turn off the very bright LEDs.
Okay.
Cool.
Let's give it a good second. Turn off.
LEDs are off.
All right. There we go. So cd. Yes. So we're going back into the JavaScript project. Type in that app. Let's see. No, and it would like a message.
Yeah.
Give me a second. Let me just look into the app to see what went on. Just to make sure, what I'm going to do is we also provide the examples on GitHub, so just to make sure that I didn't do anything wrong while I was copying, I'm just going to get the whole file we provide on GitHub, which we provide in the documentation, so you can just find the link there.
Yep.
So just here. Let me just remove app.js and make a new file. Let's call it imu.js. Paste. So
Be our network.
shouldn't really affect it. Just to make sure, I could use another terminal. Just to make sure here.
I think our network has been messing with us today.
Sorry about these technical difficulties. We're gonna try to resolve them right away. So. Okay, so seems we have some trouble here. So one more time, it's gonna
Hard reboot it.
oh, it's zippy. Okay.
Yeah, it's alright.
All right. Let's see if this does anything. If not, we're gonna have to go for a different option. You have your Raspberry Pi?
Yeah.
All right, we're gonna have to take yours instead. 'Cause something probably went wrong while I installed all the packages twice over. So something that was supposed to be shorter ended up being longer.
Maybe.
It's not ideal. So, anything? You want to get your Raspberry Pi ready?
Yeah.
So we do that. Oh, it's over here.
And get my Raspberry Pi.
Yeah. So while we try figuring it out, Carlos actually just reminded me when he said GitHub with where we have all our examples. I don't know if you guys know about this, but GitHub and DigitalOcean have partnered up with, I think it's like the 5th year in a row, to do this like really cool like Halloween initiative called Hacktoberfest. And basically it's a whole thing to promote people doing pull requests on GitHub. So basically all you have to do, you can like sign up on their website. You could like Google Hacktoberfest, and if you make 5 pull requests in the month of October, then they're gonna send you a free shirt. It's that simple. So feel free to send us pull requests. We love doing that. Ooh.
Okay, so
Okay,
I guess it
it's
was
working.
a network issue or something went wrong. But there we go. That is the live sensor data for IMU. That was the first time I ever had that like weird thing happen.
Yeah. I think
But
there's
alright,
something up with that.
So yeah, what was supposed to happen? Yeah, you get the IMU data. There it is. And right now you can see it's updating every 2 seconds, but that's normal because if you look back at what we did, scroll back up to the base port right here, we have the update set for every 2 seconds. So instead, let's change that to actually let me first close that because I forgot we edited it outside. Don't save. Let's open this back up again. Oh, well, we changed that. There we go. Okay, back to where we left off. So it updates every 2 seconds. Now we're going to do it to every 0.05 seconds.
So it's going to be really quick.
Okay,
So if we're having network issues, this will for sure make it worse.
There we go. So this is basically as fast as you normally want gyroscope data. So if you can see, I'll start moving this and the values will change. So if you look at yaw, or yeah, actually you'll just look at yaw, start noticing that, and same for pitch. And just to test the accelerometer. There we go. Spoiling this a bit. So that's all you need for connecting to any, because just doing this once just for the IMU, for example, will work on any of the other matrix sensors we provide. So that would be like LEDs, where instead of, you don't receive data aside from counting the LEDs on your device, but then you send it whatever configuration you want. So like how much red, how much green, how much blue, how much white for each LED. And okay, so we have that done. So IMU works. And now we're going to make a new file. So we're going to walk over the LED steps, because once you know the sensors, we'll just walk over the LEDs, and that should be pretty much all you need to know. And if we have time, we'll go over one little trick to show you how you can shorten your code by a lot in Core. So just to get started, we're going to make a file. So really quick, we're going to make one called, or actually just led.js. All right. So back to CyberDuck. We're going to refresh. We'll see led.js, open up in the text editor. And then we're going to go to, on the navigation, you're going to want to go to JavaScript examples and then click on Everloop. So right here, first get started. We also list the device compatibility for each the creator and the voice. And in overview, as we said before, all the 0MQ ports you're going to need are available on there. So now for the LEDs, the reason we have a data update port is because you only need to do this once, but because we want code to work on the creator and voice as much as we can, you can actually grab the amount of LEDs the device that's plugged in. So if you're using a voice, you can actually see that you're using a voice. It'll tell you. So that's why we have that port there. So just to save some time, I'm gonna grab the GitHub example, click on raw, copy that, paste it there, and there we go. And just to make sure that works, we're going to type in node led.js, and then to make sure, yeah, same as the hello world. All right. So flip that over. Okay. So back to the actual code. So for the base port, this might look like a lot of code. It's like 71 lines. Of course, remember one thing I do recommend is that it's very easy to make this into an external library, because normally when I work with Core, I'll put this as an external library and just make a simple function to just push in whatever values I want. Of course, this is a lot of code to add into whatever you're working on. It might get in the way. But because we're using servers to actually interact with Matrix Core, there is shortcuts you can do to actually circumvent some stuff. So for the LEDs, for example, the error port is always optional. Of course, we recommend having it, but if you really want to, you can still get rid of it and it will still work. So just to show you, we got rid of that, clear that, node LED.
So
yeah,
it's not spinning right now.
Spinning, and then
once he presses enter,
yeah, it's just freaking out.
It starts.
Or, no,
freaking out on purpose, at least.
Yeah. Okay. So we just skinned the error port and it still works. And of course, now the reason we have the keep alive port and the data update port is because we want to get the actual LED count. But if you only have a voice or creator and you don't really care about having them work, seamlessly, what you could do is get rid of both the data update port and the keep alive port. Let's get rid of both of those. And you're only left with the base port, which you could also right here. So the only thing we'd have to make a change for is this, because all you're actually pushing is an array of a JavaScript object that has RGBW values. So we'll just change it. How much? 35 LEDs, right?
Yep.
So 35. Save that. So we just got rid of the data update port and the error port. So let's run that.
All right.
So node app. No, sorry. Let's node LED.
There you go.
Oh,
Is
wait.
it doing it?
Let me see. And just to
Did you
make
save?
Yeah. Maybe. Let's make sure.
Oh, yeah, maybe. No.
Hold on. Let me double check this really quick.
Or did you delete a semicolon somewhere?
Nah, semicolons don't matter here. Let's see. Just to make sure, to be double sure, get a little bit too confident, and I'll bring back the error for just to make sure I know what I'm doing. Okay. Oh, there we go. Forgot this variable. Matrix device LEDs. Oh wait, did it not?
Oh, you declared it up there. No.
Did I? No.
No.
Let me make sure.
It's not fine, but where is it?
Live
Where are you
coding
going?
is not my. Oh, there we go. Okay. Send driver configuration to. Okay, so I just had that code there to wait for you to actually get the data. Forgot to get rid of that. So if I just do this, delete this one line, and I don't need the airport anymore. So run that again. So show it.
Yeah. Ta-da! That works.
There you go. So.
Cool.
Hard coding the LED count on your device can significantly reduce the code. Obviously, you know, the drawback is that if you have a voice and you want to switch between or make code that works on both, for an LED function you want to create, that's a drawback. You'll have to pick one unless you want to actually, you know, you include all of them if you want to switch between them seamlessly.
So it went from 71 lines of code down to 36.
Including all the comments
and spacing.
Yeah,
and
and of
so
course. So right now, that's all you need to know for the LEDs, and just to also show, we have a math.random function, but of course you can set it to whatever you want. So, what color do you want to make it?
Red. Just red.
All right, just red.
I like red.
Okay, so, yeah,
It's even in my name, Alf Red. See? Red
okay.
watch.
So 255.
red phone.
Actually, I'll go
I
for
really
100
like
to
red.
make it a little bit less. Okay, so right now I show them right here. So once I just set it to red, so you can see red is 100 out of 255, and green, blue, white 0.
Yeah.
So press enter, and
It's red.
It's red. First. So because of course you're just sending messages, the only parts that really matter are the lines that send and receive anything. The rest is configuration on your part, which you're free to customize as much as you want. So of course the code is flexible to use. We know that some requests say that Matrix Core can look daunting, and we understand. And of course, we do our best to explain everything that you need to know, and every line is commented, and you can shoot us a question anytime at our community page, which
is community.matrix.1.
So let me just go community.matrix.1. So over here, you can just go shoot us a question, just make an account, ask us any questions. We'll be more than happy to respond about any technical issues, or you can even just send us a GitHub issue. We'll also respond to those.
Mm-hmm.
Of any concerns or anything you want us to add for functionality. And do we have time for me to show how to port the IMU sensor to a library to shorten the code?
Um,
Oh, we could.
eh,
Or
let's leave it for another video.
Okay.
Okay.
So
Yeah.
that'll be another video.
Yeah, we're actually we're on an hour.
Okay. So
But yeah, we'll leave that for another video going more in depth of like how to use like Matrix Core with some various demos that we have. Yeah, and if you're wondering, just you want to see like real life examples of us using Matrix Core, then you can go on our Hackster page, hackster.io/Matrix Labs, and there you can see all the projects we've made, and yeah, follow them and stuff like that. We have projects on like Amazon Alexa, Google Assistant, Snips.ai, how to use the Matrix Creator's IR sensor to control the TV. I was mistaken in the link. It's hackster.io/matrix-labs.
And of course, we'll provide the links in the description of the video.
Yeah.
And just to go over one thing before we leave. So as we went over the IMU sensor and how to grab that data, I just went over to the UV sensor really quick. And as you'll see, every single component in Matrix Core, just really stressing that fact, is almost identical. Each one has a base port, keep alive port, air port, and a data update port, and they'll have their data. They're structured almost exactly the same. So once you learn one, you essentially learn them all, and that's all you need to know. And just to even show you, the Python examples are laid out exactly the same way. Of course, it's going to be slightly different, but of course, they're the same thing. Initial variables, the base port, keep alive, error port, and data update port, as well as the object, or the dictionary in this case, you're expected to get from that. And no, that's it. Matrix Core is, once you get a Hello World running, everything should come easily to you. Same for the GPIO, you can just edit that if you want to connect any external wires or whatever you want to the pins of the creator, which you can see right here. See?
Yep.
Right here. And do we have a voice here to show?
Yeah, if you take it out of the box.
So, okay. And although the port, the Matrix Voice does have GPIO pins, you actually insert them over here. And of course, we also go over that in the device setup page. Or actually, no, I think it's the overview page.
Yeah.
one of those pages, but
Yeah,
we go
great.
over everything you need to know.
Yeah, so I guess let's go to some little Q&A of questions that people have for you, Carlos.
Okay.
So first question is from Patricia. Can you explain again the benefits for having the ports enabled versus disabled? So basically, like when you were like taking out the ports, like what's the benefit of having it there versus like it not being there?
Well, I mean, functionality. But okay, so you get rid of the error port, you're not going to receive errors. So whatever the port's functionality is, when you take it away, essentially it's taking a lazy route. Is essentially what I'm saying.
Yeah.
So for testing code, it's it's one method you can do if you want to just test something out really quick. So of course, you remove the data update port, you're not going to receive data from what you're trying to get. So IMU, remove the data update port, you're not going to receive any gyroscope data.
Yeah.
So
And then let's see another question. Do you have examples of how to use the FPGA on the Matrix Creator? So I could answer that one.
Okay.
So the FPGA on the Matrix Creator, we have a on GitHub. We basically ported the programmer for how to program for basically programming the Matrix Creator, the Matrix Voices FPGA through the Raspberry Pi. And if you go on our GitHub, you can type in, I believe it's XCS3 prog, or you can go onto the Matrix Creator or Matrix Voice section of our documentation in the resources area. There will be a part on the FPGA. So Carlos will show that here in resources.
Resources.
Yeah. So right at the bottom, the FPGA. And then this is basically will show you how to use it, how to like flash it and things like that, and the source code and all that. Now, since FPGAs are very complicated, just a little rundown explanation of what an FPGA is. FPGA stands for Field Programmable Gate Array, and basically you're essentially, think of it like you're programming the wires inside the chip. Literally like, okay, making AND gates or OR gates inside in order to do math and do other things so that you can like rewire things. So we at the moment don't have any guides on how to use it. I know when we were talking with, who asked it was Raising Awesome. And when we did the interview with them 2 weeks ago, we spoke about making guides on how to use the FPGA. And that's something we're looking into. It would probably start off with like, oh, how do you do like simple microphone filters on the FPGA? And then later on like progress to, oh, how do you do beamforming on the FPGA? So things like that. Since the FPGA is so complex and we're focusing on other things, it'll take us a little bit to do that. But the more we get from the community saying that they want guides like this or like anything else, it'll raise it on the priority list. So if you have anything that you'd like us to make guides on or libraries on, or just any requests at all, please go on our community.matrix.one
and just spam us the things.
Well,
you
maybe
want.
not spam, but just like post what you want and like ask other community members to like chime in if they too want it. And we check every post, we answer almost every post, so we'll for sure see it, and it'll just help us know like what exactly you guys want. In the end, we're just trying to make what we think you guys want, and it helps a lot when you guys tell us exactly what you guys want. Any other questions? There's like a 6-second delay, but I don't think there's any other questions. Okay, so I guess now we can go on to some announcements. And if there's any other questions that you guys have, feel free to post it, and we'll say it right after the announcements now. Right. Great. Thanks, Carlos. Cool.
All right, I'll take my lead.
Awesome. And here, we'll switch chair. You
That's
go in
fine.
your... Okay.
It's fine. I'm good. I'm back. Hello. So that was awesome. We apologize greatly for the technical difficulties at first. Sadly, like Alex's section of the live stream was a little choppy, quite choppy actually. I'm being nice to myself here, but it's okay because the audio was good.
Yeah.
And, hopefully we still get, really pumped about that next project she has.
Yeah, no, I'm really excited for it.
So excited.
Yeah. Awesome.
I'm great. I'm, really glad Carlos's section, I think, went well. I think
I was checking the live stream on my phone, and, the FPS was good, so
okay.
Hopefully all's good. And hopefully YouTube, we have YouTube just recording the live stream, so hopefully it actually got the data from Alex's part good.
Yeah.
So hopefully the recording's fine. But yeah, let's get to the announcement. So we already talked about one announcement when we were talking with Alex, and that's that we will be at ARM TechCon. And so if we can go on the computer over here so we can show you the web page for it. And basically, ARM TechCon, it's this conference that ARM does every year where they get all their partners, companies they work with, companies a part of their innovator program, which we're a part of. And it's like it's free and open to the public. So you can go there, see all the booths of all the companies. And if you want, you can then pay to like go on to various sessions of like how to learn how to use X ARM technology. Like I know they're doing a lot of like machine learning stuff now with their like Cortex and microcontrollers. So that's cool. So it'll be at the San Jose Convention Center in California, October 16th through the 18th. And that's what is that? Wednesday and Thursday? I believe. Yeah. Well, actually, the expo's open 16th and 17th, so that's Wednesday, Thursday. Oh, yeah,
at a glance, Monday through Thursday, basically. Yeah. Okay. So
there you go, and you can go on their website to find out more information. And we'll be there. Samreen and I will be there with the robot arm, so you can go talk to us, say hi, and then also Alex will be there within the Hackster booth, which we're like right across from.
Yep.
So that's really exciting. And then the day after that, since this is around the time that we would be doing our next live stream, we will be at Hackster's headquarters with Alex making some cool project. And then we're still figuring out the details, but either that same day we'll like do a little impromptu live stream from our phones, or we'll just post a video like the following week with the cool project. And if you have any like suggestions of like, oh, what would you like us to make, then please go on our community or like type in the live chat now, and we'll for sure take that into consideration because we just want to make something cool. And from what Alex was talking, like she has a lot of good ideas.
Such great ideas. And like I feel like it'd be so much fun bouncing off of her because she'll say something that I'd never thought of, and then I'd be like, wait, that opens up a whole new area of my brain. That would be so much fun.
So that'll be fun. And we'll like take apart our like demo that way. One thing I wanted to do with our robot arm is kind of like strap it to my shoulder and get a top hat so that it can like tip the top hat.
Yeah, he talks about that a lot. We were like, you can do that maybe.
Yeah, I may need like goggles so it doesn't like poke out an eye, but I kind of want to do that. It'd be fun. It'd be very fun.
It probably would.
It would. Okay. And then what was the other announcement that we wanted to do?
I mean, it was mainly the TechCon. We wanted to show you guys the magazine, which we showed you as we were talking to Alex. I wanted to tell you that we were going to have another live stream with Alex in person, so hopefully we won't have as many technical issues.
Yeah.
And
I think that was it. Yeah. And I guess Carlos, do you want to say anything about your little special project, or you want to wait for that? Wait a bit for that. Wait a bit. Okay, so you'll find out in another live stream what it is. We may have a little foreshadowing earlier about it, but
actually, I'm pretty sure it was explicitly said already.
Yeah, but now you have to go back and check
look at
what it could possibly be.
Oh, we have some questions.
Okay, so. Okay. Yeah, so we'll get to the question. Oh, thank you. Time limit on iOS 12 telling me I've been on YouTube too much because I watch way too much YouTube. Well, okay, so let me see what the questions are. I found the pitch and to be pretty consistent with values. They all seem to be very... I can't code to it. Is there a calibration for yaw or any other aspects I should be considering? So this is from Raising Awesome, and he asks, I have found the pitch and roll to be pretty consistent in their values. However, the yaw seems to vary such that I can't code to it. Is there a calibration for yaw or any other aspects I should be considering? So the answer is yes, there is a calibration for yaw. Do we have it in the docs?
No, we have to add that. I can ask one of our hardware developers. Fill me in on that.
So so that would be Carlos will work with Yoel to add it to the docs, and it should be on the GitHub. If you search on our community, there should also already be something on there. If not, just ask the question on the community, and Yoel and Carlos will respond with the link to how to calibrate the yaw
or the steps.
Yeah, or the steps too. Yeah. Okay, let's see what else. It'd be nice to have that. So, Henry Oliver asks, it'll be nice to have an episode creating an app from scratch using Matrix Creator functionalities. Yeah, definitely. We could like set up a whole like cool episode guide to do that. I'm trying to think what we could do. If you have any ideas of what you'd like us to do, we can
Please
for
let us
sure
know.
put it. If anything, we could. When we're with Alex, we could kind of make the live stream a bit like that, of showing you like how we're creating the project that we end up creating.
And you know, this is just the beginning, so we will be doing many more live streams with, you know, projects that we will hopefully be doing from scratch. Some cool ones, some replicable ones.
Yeah.
But yeah. So for sure, if you have ideas, please leave comments. Otherwise, like, we'll definitely get to that at some point.
Yeah. And then one more question. When I do a package update, the ALSA sound drive of the Pi tend to be belly up, requiring some confusing gathering of files. Is this anything you guys go through on updates? So, Raising Awesome asks again, when I do a package update, the ALSA sound drivers of the Pi tend to go belly up, requiring some confusing gathering of files. Is this anything you guys go through on updates?
I've never experienced that.
Yeah, I haven't either.
Maybe send us screenshots of it.
Yeah, screenshots, like copy and paste the
the
like terminal
community.
outputs and errors that you're getting, and put it on the community, and then we'll be able to.
Just to get in here.
Yeah.
Here, better.
Yeah.
Okay, everyone's here, the whole gang.
Okay.
Just post that on the community, and we'll get to that.
And
I
also
know
the steps you like from when you have the Pi, like what steps you follow. So say if you installed the kernel modules, or if you got the microphone from just C++ from HAL.
Yeah.
It'd be helpful to know, because we try to replicate them if we can, and that'll help us a lot in debugging.
Yeah, and then Henry Oliver asks, how about the wake word feature?
So for the wake word feature, it has been a little dodgy from what we noticed. We are working on that, and as an alternative for now, we recommend using snips.ai, which we have a guide on Hackster. Which do you want to add that in the description?
Wait,
we'll add to the description of this video, but you can also just go to our Hackster page, hackster.io/matrix-labs, and you'll see like the snips guide is one of the first ones there.
Yeah, and we know we can use Python, which is one of the guides they have it for, and as well as JavaScript, and I'm not sure if they have any other guides. But...
I've seen Python and JavaScript, but you could just make a little Python or JavaScript file and then pipe that to something, or call that from some other program. So that shouldn't be too hard. And then if you specifically want to use Pocket Sphinx, which is what we use in our wake word library within Matrix Core, we have a C++ example on our GitHub of how to set up Pocket Sphinx with the Matrix Creator or Matrix Voice. So you could just look up Pocket Sphinx on our GitHub, which is github.com/matrix-io, and you'll be able to find that there. And any other question? Matrix Voice with custom wake word integrate with Dialogflow. So yeah, I mean that would basically just be a view. Henry Oliver says Matrix Voice with custom wake word integrate with Dialogflow. So
for that one, that'd be a personal project, so you'd have to look into that for part of it. But from what I've seen on the community, one alternative could be you use Snowboy, which is a wake word that you can set for yourself. And then for the Dialogflow services, you can see if there's anything you can use, because I'm aware that Google Assistant uses that for some of its features. But I'm sure there's some libraries that'll allow you to use that easily. So that'd be up to some research. And if you really need some help, or if you want some help creator specific, you can just hit us up on the community and post whatever question you have. And
yeah. Okay, so we can wait 6 more seconds for the chat to catch up if you have any more questions. Otherwise, we'll be closing it out.
Yeah, and if you have further questions, you can always comment. We'll get to them, or post on our community, all that stuff.
Yeah. And if you have any requests for projects, what you'd like us to do in live streams, or anything else, like comments on the live stream, go on our community. We're super responsive with that.
Speaking of projects, the projects category is open, has been open for a week.
Yep.
So please post your projects, because what better way to get feedback on what you're doing and help on stuff.
And Samarine's referring to the projects category on the community. So on it, you'll see like tabs of like general discussion, announcements, help, and projects. Oh, okay. So one more question. Let's see. Just
Hello, Henry. You're welcome.
40 game engine.
Yeah, you're welcome.
Brand for the real life. Ooh, okay. So if you had tuned into the live stream from 2 weeks ago, Raising Awesome had talked about this like 4D game engine project that they were building, and so they say now that just for info, for the 4D game engine project we are making for the Element 14 Presents channel, the Matrix creator is the brain for the real life boss battle character.
Wow!
So they basically made this kind of like a Five Nights at Freddy's game on Steam, and they've set it up so that you can hook up various hardware devices so that while you're playing the game in like VR using like an Oculus Rift and probably a Vive 2, you can have like actual things in the real world reacting to the game. And so he's saying that they're using the Matrix creator as the real life boss for the game. So I'm really curious as to what that is.
Yeah,
That's
so
gonna
excited.
Be fun.
It's called Sleepwalkers. So check it out.
Nice.
I think I may have gotten it wrong. But go check out our last live stream with Sean and Connor to be sure about that. They also give us like a little like hint on like something cool in the game.
Yeah, so go check
watch
it out.
The other live stream, yeah.
Or maybe you can put it like maybe if you can post it as a comment after the live stream ends, so somebody just see it right there. But...
Yeah. Okay, well, I guess that's it. Thank you, everyone, for watching. Thank you, Alex. I imagine you're still watching. Thank you for that the awesome projects, and we're really excited to be working with you in San Francisco in 2 weeks. That's going to be super fun.
Yeah. Thank you for sticking with us, and we'll see you next time.
Yeah, thank you. Bye.
All right. Cheers.
Awesome.
Make sure it's up.
Bye.
Mute the mic.